Hey everyone, it's You'll Be Blessed here, making it clear, making it plain, opening up the heavens for my teaching is like spring rain. And today we're going to answer the question, what is an empirical formula? All right, so let's get started. What is an empirical formula? And this is part of the chemical composition series, okay? So our objective for today is we're going to be able to find the common factor in the subscripts of a chemical formula in order to test for the empirical or the molecular formula. So there's two types of formulas. There's an empirical or molecular formula, and I'm going to go into more detail about that. All right, so the key concept here is relationships between measurements determine the form. What do I mean by that? Let's elaborate. The relationship that we are exploring is the law of definite proportions, and that means that atoms combine in fixed whole number ratios. The measurements that we often take with atoms are typically the mass of the atoms and the number of atoms, and they're usually directly related to one another, okay? And so today we're just going to focus specifically on the number of atoms and then finally the form. So there are two forms, the empirical formula and the molecular formula. And each of them have some similarities and they also have some differences, okay? So we're going to learn how to be able to test for the two types. So what is an empirical formula? Well, the empirical formula is the reduced or simplest form of a chemical compound. All right. So in this example here, you might remember this, or this looks familiar from maybe biology, but you have the formula C6H12O6, which is a molecular formula. It is molecular because it is not reduced. Okay. All right. C6H12O6 is not empirical. It is not empirical because it can be reduced by a common factor. So if you look to the right, you're going to see C6H12O6 in yellow, and we're going to just look at this really quickly. So what is a common factor between 6, 12, and 6? Those are the subscripts of this chemical formula. Well, this leads us to 6. 6 is divided by 6. 12 is divisible by 6, and 6 is divisible by 6. So they have a common factor of 6. So when we divide each of those numbers by this common factor, all right, or the greatest common factor, you can even say that, you get C1H2O1. In chemistry, since we do not typically write the 1, this simply reduces to CH2O. And so CH2O is actually the empirical formula, whereas C6H12O6 is the molecular formula. So the molecular formula is actually scaled up from the empirical formula, and the empirical formula is reduced down to a very simple form, or the simplest form you can find. It is the simplest whole form with whole number ratios, okay? So let's get some practice in. Which of the following is an empirical formula? Is it going to be C4H10, C6H14, or C5H12? So let's go through these one at a time so that you can follow my example, okay? If we examine C4H10 first, we're going to try to divide all of these by a common factor of 2. Okay, we can do that. And so because it has a common factor, all right, both numbers 4 and 10 are divisible by 2. C4H10 cannot be empirical. It's not reduced already, okay? So then let's look at the next answer. We got C6H14. Well, if we look for a common factor between 6 and 14, we end up with 2 again, all right? So since these two formulas have common factors, they are actually not empirical formulae. All right, so if we examine C5H12 for a common factor, 5 and 12 don't have any common factors other than 1, okay? So even if we tried to divide both of these by 5, 12 is not divisible by 5. That would give you a fixed whole number, okay? And because of that, because this cannot be reduced any further or simplified any further, the answer is C5H12. So in this next example, we have different combinations of iron. Okay, I'm not going to give the names because it might spoil the answer, but which one of these is actually not an empirical formula? So which one of these is not reduced? Okay, So if we have Fe2O3 as our first choice, we have Fe2O2 as our second choice, and then we have FeO as our third choice. Why don't you take a minute to determine which one of these is not an empirical formula? And I hope you guessed that I don't like guessing. I hope you actually tried to figure out that the answer actually is B, Fe2O2. B is not an empirical formula. So the next question I'm asking you is, why is Fe2O2 not an empirical formula? Well, if you were to look at each of these answers, okay, we can look at answer A, Fe2O3. There is no common factor other than 1. If we try to divide them by 2, we don't get a fixed whole number. If you look at B, there is a common factor of 2, and we can divide each of those subscripts by 2, and actually Fe2O2, when reduced by a factor of 2, actually gives you the answer C. All right, so Fe2O2 reduces to Fe1O1. Okay, so FeO was actually already reduced. So this is actually the reason why Fe2O2 is not an empirical formula. It's because it contains a common factor and you can still reduce it even further to a simpler form. Okay, so here's our last example before this first part of this instructional video is over. So here's our last example. And I tried to keep this as simple as possible. So which of these, again, is not an empirical formula? So we have the names now, because it's not going to give away the answer. So we have lithium nitride, which is Li3N. We have calcium oxide, which is CaO. We have aluminum oxide, which is Al2O3. And we have aluminum nitride, Al3N3. So again, which of the following is not an empirical formula? All right, well, the answer is definitely Al3N3, aluminum nitride. So the name is correct, but the formula is not an empirical formula. So let's talk about why. Why are Li3N, CaO, and Al2O3 all considered empirical formulae? Why are they empirical formulae? And if we are to look at these, we're going to look at them in pairs. Lithium nitride and Li3N, all right, they only have a common factor of 1. Even if you try to divide these by 3, you can't reduce this any further because 1 divided by 3 will give you a decimal. It's not a fixed whole number ratio, so it's already reduced. Calcium oxide, CaO, have subscripts of 1 each, even though they're not written there. So they are actually already reduced. They have a common factor of 1. That's the only common factor again, all right? So next we have aluminum oxide, Al2O3. And if we were to examine these, Al2O3 also has a common factor of only 1. Even if we try to divide these by 2, we cannot get a fixed whole number ratio. 3 divided by 2 is going to give us 1.5. So that's not a whole number. So aluminum oxide, Al2O3, is already reduced. So then this leads us to our final answer of aluminum nitride, Al3N3. They both have a common factor of 3 and 1, or 1 and 3. So this is not reduced. Because they have common factors other than 1, it is not reduced. So therefore, that's the reason why lithium nitride, calcium oxide, and aluminum oxide are empirical. The pattern again is they have a common factor of 1 and only 1. But aluminum nitride has a common factor of 1 and another number. All right, so that's what separates an empirical formula from a molecular formula. Thank you for tuning in to You'll Be Blessed Education. I really hope you were truly refreshed by this teaching. And if you were, there are several things you can do. First, you can click the like button below. Second, you can leave a comment below describing how you were blessed by this video. Third, share this video with anybody you know that will be blessed by this teaching. Again, thank you for tuning in to You'll Be Blessed Education. This is You'll Be Blessed. Be blessed. I'm out.